Okay, so today we're going to go on and now that we know how to identify oxidation states for individual compounds, we're going to actually start looking at some oxidation reactions and seeing what's going on during those. So we've already seen this one, but let's take a look at it again. You have sodium chloride plus fluorine goes to sodium fluoride plus chlorine. And the way we know this is an oxidation state reaction, oxidation reduction reaction, or redox reaction, is because the oxidation states are changing. So chlorine is, or sodium is a +1, chlorine is a -1, fluorine is a 0 since it's in its elemental form. Sodium over here stays a +1, fluorine goes to a -1, and then chlorine goes to a 0. So what we see is two atoms or two elements here change their oxidation state. So fluorine went from a 0 to a -1, and chlorine went from a -1 to a 0. So we can think of how the electrons are being transferred in this case. So fluorine went from a 0 to a -1, so it's actually adding 1 electron. Chlorine went from a -1 to a 0, so it is losing 1 electron. If we remember back to our definition for redox reactions, oxidation reduction reactions involve a transfer of electrons. So what we see here in this particular reaction, chlorine is transferring its electron to fluorine. Okay? Or we can break it down a little bit more. There are two halves to this reaction. One thing is being reduced and one thing is being oxidized. So let's take a look at those. So let's look at the oxidation half reaction. Okay? So a way to remember this is Leo says Ger. This is how we identify what's being oxidized and what's being reduced, what the half reaction is. So loss of electrons is oxidized. So if I lose an electron, I'm being oxidized. So let's look at the oxidation half reaction. So in this case, which one is losing electrons? Well, chloride with a -1 charge, okay, two of them, are going to chlorine with a 0 charge plus 2 electrons. Since each chloride is losing 1 electron, two of them are losing those 2 electrons. So this is my oxidation half reaction. And let's take a look at the reduction half reaction. So in the reduction half reaction, gain of electrons is reduction, Ger. We have fluorine going to 2 fluoride ions. Okay, well, how do I get over here? Well, I'm adding in 2 electrons. So fluorine plus 2 electrons goes to fluoride, 2 fluoride molecules. So these are called half reactions. And for redox reactions, they show us really what's going on. Why did this reaction happen? What happened? Well, chlorine lost 2 electrons and went to chloride, lost 2 electrons and went to chlorine, each 1 electron each. Fluorine, those 2 atoms of fluorine, each of them gained 1 electron or 2 electrons total and went to fluoride. Okay, so that's called a half reaction. Let's take a look at another one here. Let's say we have this reaction. So zinc metal plus hydrochloric acid goes to zinc chloride plus hydrogen gas. You guys have seen me do this. This is normally how I fill up that balloon to blow it up. So let's identify the oxidation states real quick and see if we have a redox reaction. So zinc has a charge of 0, hydrogen has an oxidation state of +1, chlorine has an oxidation state of -1. Okay, on this side now, zinc is in a compound, so it has a charge of +2. It's a chloride, so it has a -1 charge. And then hydrogen is by itself, so it has a 0 oxidation state. So let's look. Do we have elements that change their oxidation state? So zinc went from a 0 to a +2. Well, how do you do that? It lost 2 electrons. Hydrogen, on the other hand, went from a +1 Now it goes over here to a 0. So what did it do? It gained 1 electron each. Okay, or each total of 2 electrons, but each hydrogen atom gained 1 electron. So let's break that down and look at the half reactions here. So for the oxidation, so let's remember Leo says Gur. Loss of electrons is oxidation. So let's look at the oxidation half reaction first. We have zinc metal going to a zinc ion with a 2+ charge. Well, how did it do that? By producing 2 electrons. Then for our reduction, we had 2 hydrogen ions going to, okay, and if reduction, we're gaining electrons, so we're going to add in some electrons here, and it's going to go to elemental hydrogen with a charge of 0. So if I have 2 positives and I go to a charge of 0, I need to add in 2 electrons. So in this case, we have 2 electrons been transferred on each side. So this is really what's going on. Now, why does this happen? Well, what's going on here is there's a battle for these electrons, okay, between zinc and hydrogen in this case. So in this particular reaction, who wants the electrons more? Well, hydrogen does, because it takes them and it ends with those electrons. Let's look at one more example here. So let's look at magnesium plus silver nitrate goes to silver plus magnesium nitrate. Now what you notice is I didn't actually balance this. We're going to come back and do that here in a second. So oxidation state 0, plus 1, minus 1, 0, plus 2, that's still minus 1. So let's look at what's been oxidized. What lost electrons? Well, magnesium goes from a 0 to a plus 2. So if it goes from if it becomes more positive, it lost those electrons. So we have Mg goes to Mg 2+ charge plus 2 electrons. Now let's take a look at what is being reduced. What's the reduction half reaction? If something is being oxidized, okay, something else has to be being reduced, right? If I'm producing electrons, something else has to take or consume those electrons. So in this case, nitrate goes from -1 to -1, so nothing happened with it. But silver goes from a +1 to a 0. Well, how do you become less positive? Well, you add in more electrons. So we had silver, +1 charge, plus some electrons going to silver solid with a 0 charge. Well, how do I get from a +1 to a 0? By adding in 1 electron. Okay. Now, if we look at this half reaction here, are my electrons balanced? Magnesium is producing 2 electrons for every 1 magnesium ion, and silver only needs 1 electron per silver ion. Okay, so our electrons are not balanced in this case. So what do? We want to multiply this bottom one by 2. I need 2 silver ions. That'll need 1 electron each, or 2 electrons total. I'll get 2 there. Now my moles of electrons are balanced, and my half reactions are balanced. So what you can do is you can take these coefficients up to the original reaction up here. So magnesium plus 2 moles of silver nitrate goes to 2 moles of silver plus 1 mole of magnesium nitrate. So again, with this same reaction right here, we have 2 half reactions. Something is getting oxidized by losing electrons, Leo, loss of electrons is oxidation. Silver down here is gaining electrons, Gur. Gain of electrons is reduction. Leo says Gur. So half reactions, what they allow us to see is better understand where the electrons are coming from and where they're going to. Okay? So before writing the oxidation states and all that stuff up here, looking at this half reaction, we just thought, oh, that's a double displacement or a single displacement reaction. But what half reactions allow us to do is actually take a look at what is making this reaction happen? Magnesium is losing 2 electrons and silver is gaining those 2 electrons. And that's what makes that a reaction occur. Okay, so in this case, we could say, who wants the electrons more? Well, silver wants the electrons more than magnesium. So this right here is what drives this reaction up here. Silver is taking those electrons, silver ions, are taking those electrons from solid magnesium, producing solid silver, and then leaving magnesium in a compound with nitrate. All right, so there's an introduction to half reactions for redox reactions. Make sure you watch, as you watch this, hopefully you took some notes and have any questions that you might have for me so I can answer those in class. Hope you guys have a great day.